Welcome back. Let's discuss section 22.4, the two-sample z-test. What we're going to be doing is setting up a hypothesis test for the difference between two proportions. Let's suppose we have two populations. I'll call them population 1 and population 2. They're represented by these large circles that I've drawn. Maybe population 1 is the group of all teenagers. Population 2 is the group of all senior citizens. I'd like to know, is the proportion of teenagers who text on a daily basis the same as the proportion of senior citizens who text on a daily basis? Now, I don't actually know these population proportions P1 and P2, so I'm going to need to draw a sample from each population, and that's what I've indicated by these smaller circles here. P1 hat will be the sample proportion of teenagers who text on a daily basis, and P2 hat will be the sample proportion of senior citizens who text on a daily basis. Maybe I notice that P1 hat is quite a bit bigger than P2 hat. I'd like to know, is this difference real or just due to natural fluctuations in the sample? So we're going to do a hypothesis test, and it's a pretty natural choice for the null hypothesis. We assume there is no difference in the proportions. That is, P1 minus P2 is equal to 0. Because of the difference I noticed in the sample proportions, though, I suspect the true proportion of teenagers who text on a daily basis is greater than the true proportion of senior citizens who do so. So the alternative hypothesis is that P1 minus P2 is greater than 0. So let's go back to the example we looked at in the last video when we set up the confidence interval for the difference in two proportions. Here's the example from last time. We've got a group of individuals who are wanting to quit smoking. They're going to use a nicotine patch. And some of the individuals are also going to attend a support group. So we've randomly assigned the individuals to two groups. Group 1 will use the nicotine patch and attend the support group. Group 2 will use the nicotine patch and not attend the support group. We found that 46 out of the 143 individuals in Group 1 were able to stop smoking, or quit smoking, I should say, and 30 out of 151 of the individuals in Group 2 were able to quit smoking. So the proportion, the sample proportion from Group 1 is quite a bit bigger than the sample proportion from Group 2. Do these results suggest that such support groups could be an effective way to help people stop smoking? The null hypothesis asserts there is no difference in the proportions. In other words, P1 minus P2 equals 0. Now, based on our sample proportions, we suspect that attending a support group is helpful for individuals wanting to quit smoking. So the alternative hypothesis is that P1 minus P2 is greater than 0. In other words, P1 is greater than P2. So we're going to assume the null hypothesis is true. This says that the proportions are equal, so there should be just a single value of P hat in the standard error formula. If you recall, the standard error formula involves two proportions, P1 hat and P2 hat. So we'd like to somehow combine these two proportions into a single proportion. We get an overall proportion called a pooled proportion. Now, we didn't do this when setting up the confidence interval because we weren't assuming the two proportions were equal there. But this will give us a little bit better estimate by doing a pooled proportion. So here's how we calculate that pooled proportion. We'll denote it p hat pooled. We're simply going to take the number of successes from group 1, that was 46 individuals who quit smoking, plus the number of successes from group 2, that was 30 individuals, over N1 plus N2, the sample size of the two groups. So we end up with p hat pooled is equal to 0.259. And now we'll use this single proportion in our calculation of the standard error, which I'll write standard error pooled of p1 hat minus p2 hat. So in place of p1 hat, we'll use p hat pooled, and in place of p2 hat, we'll use p hat pooled. So we end up with 0.259 times 1 minus 0.259 over the size of group 1, 143, plus 0.259 times 1 minus 0.259 over the size of group 2, 151. And this gives us 0.051. Now we can calculate a z-score. We'll take the observed difference between the sample proportions, p1 hat minus p2 hat, minus the hypothesized difference in the two proportions, that's 0, over the standard error pooled. So in this case, we have 0.322 minus 0.199 minus 0 over 0.051 to give a z-score of 2.41. Next, we'll calculate a p-value. The probability that z is greater than our z-score of 2.41 is roughly 0.008 from table Z, and this is a fairly small p-value. The very low p-value indicates the observed difference is unlikely to be just sampling error, so we reject the null hypothesis. There is strong evidence that being part of a support group can help nicotine patch wearers stop smoking.